This next graphic is also utilizing the terminology of field capacity, wielding coefficient, hygroscopic coefficient, as well as available water and etc. over here. I'm utilizing this one to further explain to you or show to you the relationship between the soil moisture potential, remember the total energy potential of water, soil water content, and the terminology that I've just introduced in terms of water being held in the soil at different levels. We start out up here at saturation. At saturation, we may have approximately 50% of the total soil volume occupied by water. In this case, it shows slightly over 50%. This water held between saturation and field capacity is not available to the plant. Perhaps a small portion might be if the crop were already there and established, but this water, the free water, the gravitational water, which is indicated between saturation and field capacity, is not held there long enough to be of any practical significance. Once that soil reaches field capacity, then that water will be held in the soil profile until we get a utilization by plants. So plants are utilizing that water held between field capacity and the wielding coefficient. Now if we refer over here to the right-hand side of this diagram, we see that that between field capacity and wielding coefficient is called available water. It's broken into rapidly available and slowly available. Obviously that up near field capacity is taken out quite rapidly. That closer to the wielding coefficient is much more slowly available. Shows an optimum zone between field capacity and about 60% of the way down to the wielding coefficient. Within this zone of water utilization, we would not expect a significant decrease or reduction in the yield potential of a crop. However, if we start to go below this optimum zone into this slowly available water, we could expect, especially on some sensitive crops, a significant reduction in yield if we force them to utilize the lower end of this available water. And then finally, our last term over here is capillary water. And see that capillary water is everything held or retained in the soil pores between the field capacity and clear down here to the level of hygroscopic water in the soil. So our hygroscopic coefficient, capillary water is a slightly greater amount than is available water. So available water is that portion of capillary water that plants can actually utilize, recognizing that there's a small amount down here between the wielding coefficient and the hygroscopic coefficient that is still a part of this capillary water. Water held beneath the hygroscopic coefficient, for all practical purposes, is not removable, is not usable by plants certainly. So this hygroscopic water is really of not a practical significance to us, other than the fact that it is there, that we don't actually remove all of the water from the soil particles. Even when we take this water, when we take this soil and put it in a soil's drying oven to determine the gravimetric water content, under those situations we are still not removing this hygroscopic water. It's molecularly bound water right adjacent to the surface of the soil particles, and it's just not very much, and it's just not usable. So we're relating all of these values here, field capacity, wielding coefficient, etc., on the right or the lower axis of the graph in terms of soil moisture potential, the total potential energy of soil water. And remember, this is in kilopascals, so we'd have to move this back a couple of decimal points. Field capacity would be about 0.1 bars or atmospheres of total soil water potential. And the wielding coefficient, as shown here, would be about minus 10 bars or atmospheres of soil moisture potential. And you can see that we might go from a minus 10 up to a minus 100 before we actually reach that hygroscopic coefficient. Field capacity of a soil is a soil-dependent property. More than anything else, textural class, but also modified by organic matter content and soil structure, will determine the field capacity, but those are all soil inherent properties. The wielding coefficient is a plant-dependent property. To what level of water we can expect that plant to withdraw from the soil profile, that will be dependent upon that particular species of plant and its water use abilities from that soil. So field capacity is dependent upon our soil type, texture, structure, organic matter content, etc. Wilting coefficient is dependent upon our crop type or plant type that is actually withdrawing the moisture from that soil profile.